Hello everyone, today we will work through Chapter 6 AP Statistics Practice Test. If the questions in the practice of statistics, the textbook, and it's on page 436. You can open to that page and read all the questions and do it with me, but today we will do that together. So I will read out the first question. Refer to the following setting. A psychologist studied the number of puzzles that subjects were able to solve in a 5-minute period while listening to soothing music. Let X be the number of puzzles completed successfully by a random chosen subject. The psychologist found that X had the following probability distribution. You can see the table. Value 1 has probability 0.2, 2 has 0.4, 3 has 0.3, and 4 has 0.1. So the first question, what is the probability that a random chosen subject completes more than the expected number of puzzles in 5 minutes period while listening to soothing music? So in the first question, we're going to find the expected number of puzzles, which is the mean first. So you know how to find the mean is the value times the probability and plus together. And you put that into your calculator and you will get the number. So I will just use it later or now. So 1 times 0.2 is 0.2 plus 2 times 0.4 is 0.8 plus 0.9 plus 0.4. So we got 2.3. The exact number is 2.3. Then we will see what value has exceed the 2.3. So obviously it's 3 and 4. Then we add the probability of getting 3 and 4 together, which is 0.3 plus 0.1 equal to 0.4. So as you can see, the answer is B. Now we go to the second question, which is the same setting, but different questions. The standard deviation of x is 0.9. Which of the following is the best interpretation of this value? So we know that standard deviation is how much the number from the mean. So if you read through all the 5 choices, you will know that okay, let's read through all the choices. A. About 90% of subjects solved 3 or few puzzles, which is obviously wrong. Wrong. About 68 of subjects solved between 0.9 less and 0.9 more than the mean, which is also wrong. The typical subject solved an average of 0.9 puzzles, which is also wrong. The number of puzzles solved by subjects typically differ from the mean by about 0.9 puzzles. This one is correct, but we can read the E, C, and see the E. The number of puzzles solved by subjects typically differed from one another by about 0.9 puzzles. Oh, E is wrong because it said differ from another, but standard deviation is different from the mean. So E is wrong. The correct answer is D. Now let's go to the next question. Let D be the difference in the number of puzzles solved by 2 randomly selected subjects in 5-minute period. What is the standard deviation of D? So we know that D is the difference in number of puzzles solved by 2 randomly selected subjects. And it asks what's the standard deviation of D. So it means the difference of standard deviation. So let's see if we can solve it. Oh, it's easy. We already know the standard deviation is 0.9 previously. So the only thing we need to do is square root the variance of the standard deviation and add them together. So I will show you in decimals because we can't type square root in Word, so I will show how will we answer it. Is square root 0.9 plus square root 0.9, which is equal to equal to 1.2727. So as you read the answer choice, A is 0, B is 0.81, C is 0.9, D is 0.17, so the answer is D. Now we go to the fourth question, which is in a different setting. Suppose a student is randomly selected from your school. Which of the following pairs of random variables are most likely independent. So we want to find two variables that the probability of the first variable doesn't affect the probability of the second variable, which means they are not affected by each other. So we will answer choice A. X equal to student's height, Y equal to student weight. There is a relation between them and they're not independent, as you can imagine. If a person is taller, then maybe the person is more heavier. B, students IQ and the student's GPA is not dependent, is not independent, because if a person is smarter, maybe will get higher results. C, X equal to student's PSAT math score, Y equal to student's PSAT verbal score. It is also not independent, because if you can score higher in one subject, maybe you can also score higher in another subject, because you are good at all of them. D, let's go to D. X equal to average number of homework the student does per night. Y equal to student GPA. This is not independent, because if a student do more homework, that means that the student paid more time into study, so the student's GPA can get higher by more practice. So it's not D. And E, the amount of homework the student does per night and the student's height. Oh, it's E. E is the correct answer, because even if you do many homework, it doesn't help to predict your height. So it's E. Now we go to the next question. A certain vending machine offers 20-ounce bottles of soda for $1.5. The number of bottles export from the machine on any day is a random variable with mean 50 and standard deviation 15. Let the random variable y equals to the total revenue from the machine on a random selected day. Assume that the machine works properly, that no sodas are stolen from the machine. What are the mean and the standard deviation of y? In this question, there's many words in this part. We can find the keyword here. The x variable has mean 50 and the standard deviation 15, and we can write them down, and we can see y equals to the total revenue from the machine on any selected day. So we can know that the y will be equal to the mean and the standard deviation of y will be equal to the mean and the standard deviation of x multiplied by 1.5. So let's get the calculator and multiply 50 times 1.5 is 75, and the standard deviation times 1.5 is 22.5. So because if you multiply a number to the whole, to the whole variable, the center and the spread will change. But if you add or subtract, then only the centers change. So as we calculated, that we know is d mu equal to $75, standard deviation equals to 22.9. I'm wrong, 22.5. So dollars. So let's go to the question 6. The weight of tomatoes chosen at random from a bin at the farmer's market, followed by a normal distribution with mean equals to 10 ounces and the standard deviation equals to sigma equal to 1 ounce. Suppose we pick 4 tomatoes at random from the bin and find their total weight t. The random variable t is, so now it's also adding the mean and the standard deviation. And in this question, we should not be tricked by 4 tomatoes. They want 4 potatoes, we will add them together. We don't do multiply. So as we add them together, 10 plus 10 plus 10 plus 10 equal to 40. So this is the mean. Okay, and the standard deviation is equal to, okay, I will show you in decimals again, is 1 squared, which is 1, plus 1 squared, plus 1 squared, plus 1 squared. So it's equal to 2. So standard deviation is 2. So we can find the answer is, we need to determine its binomial or normal. But the question already say is normal distribution, so it's B, normal with mean 40 ounces and the standard deviation of 2 ounces. So it's B. Now we go to the question 7. Which of the following random variables is geometric? This is a bit tricky. The number of time A is the number of time I have to roll a single die to get 2 6s. So as we know, geometric random variable is how many trials you need to get one success. And it's get one success, and here says get 2 6s. So maybe I'm saying something wrong, but A is not correct. A is not correct. So number of cards ideal from a well-shuffled deck of 52 cards to get a heart. This is B. Okay. Oh, I remember something. We need to go through the step by step. First, we need to determine success and failure. So the success can be get a heart, and failure can be not getting a heart. Then we will see if the probability is independent. So as we can see in the B, if we keep pulling cards out of the deck, the probability of the first card and the probability of second card are not independent and are not the same. So B is wrong. Now we go to C. The number of digits I read in a randomly selected row of digits table to get a 7. So let's do it again. What's the success? Get a 7. Failure, not get a 7. And are they independent? Are the probabilities independent? So as you read through the random digits table, I think the probabilities are independent and they have the same probability. And we don't know but I cannot tell why they are independent. The number of digits I read in a randomly selected row of random digit table to get a 7. Oh, let's see if you get the first number. If you move from the left to the right, from the first number to the last number, and I think the probabilities are the same. I can tell. So let's go to D. The number of sevens in a row of 40 random digits. This is wrong because it didn't even define what is success and what is failure. And E, the number of sixes I get if I roll a die 10 times. This is also didn't say the success and failure. And it didn't tell the probability. So I think the answer is C. Let's go to 6.8. Because the questions in 6.7 is tricky. And it's very easy to get a question wrong. I need to say that I did this before, but it's a very long time ago, so I almost forget the the answer, so now I'm doing them again. So 6.7, 6.8. 17 people have been exposed to a particular disease. Each one independently has a 40% chance of contracting the disease. A hospital has the capacity to handle 10 cases of the disease. What is the probability that the hospital's capacity will be exceeded? I remember these 40% is contracting the disease. So we got 60% that cannot contract and need to go to hospital. So the hospital has capacity to handle 10 cases of the disease. What is the probability that hospital capacity will be exceeded? Or if we want the hospital to be exceeded, so we must got more than 10 cases. So I will put x bigger than 10. So now we go to the calculation part. Probability of x larger than 10 is equal to 1 minus probability of x less than or equal to 10. I will got a sign of less than or equal from here, and I will copy it from here and put it here. Oh, we can't. Okay, so you know it's, I will just write it here. 1 minus probability of x less than or equal to 10. Now we need our calculator. Okay, I will put the original one here. Now we need our calculator. It equals to, I will write the construction here. 1 minus binomial CDF, which is, you will see in the calculator. And first we need to see the number of trials. Trials should be equal to, oh, it should not be binomial since we don't know the total number of trials, so it's geometric. Oh, I hope I'm not doing something wrong. Geometric CDF. And first we need to type the probability is equal to 0.6. Then the x value, which is equal to 10. Now you put that into your calculator, and I'm going to get my calculator. Okay, did you get the answer? Okay, I'm come back. Oh, I'm just doing something wrong. Oh, I'm not doing something wrong. Okay. Here is wrong. The lower bound is 1. The upper bound. Okay, it's just I forget the instructions in the calculator. And oh my god, what I'm doing. Oh, what I'm doing is wrong. Oh, sorry. I'm really sorry that I didn't read the question very carefully, so I tell you the wrong answer. I'm sorry. In the question, the first sentence said 17 people, so the total trial is 17. Then let's see the instructions. 17. Oh, then probability is 0.6 because it's a probability that they need to go to the hospital. And lower bound 0, upper bound 10. And I think if you put this into a calculator, you will get the answer. Oh, I'm still not correct. I'm still not correct. What? Okay. Okay, wait. I'm sorry. I'm sorry that I did something wrong. I did something wrong. Okay, give me some time to think. I mean 1 to 2 minutes. Oh, I know. I mean, why I'm wrong. I need to subtract the probability that 10 people can contracting the disease. Okay, I promise I didn't look at the answer at the back. At the back, I didn't. I didn't. So this would give you 0.07. Oh, 3, 4. Yeah, there's a helicopter. 0.0348131 which is very close to the answer 0.035. So it's B. Oh, that's so hard. Now we go to 6.9. 6.9 is that the figure shows the probability distribution of discrete random variable x, which of the following best describes the random variable. And you get the graph. If you have the book, you can see the graph. A binomial with n equals to 8 and p equals to 0.1. Okay, I must say that there's no some intelligent way to solve the question. You just need to put all the answer choices into it and see if okay, maybe oh, it's 0.3. Okay, we go back to the question. And now we need to think, what if we don't have the software I have, then how can people solve the question? Okay, you can just go to your calculator and go to binom CDF. I think go to binom CDF and you put the number of trials 8 and 0.1. And you can see it in the graph is 0 to 6, so from 0 to 6. Oh, I'm sorry. Or I think you can just type and you can just try to get the mean of binomial by times the trial to the probability, which is NP. So I'm doing it. And in the graph, you can kind of see where the mean should lie. Actually, I'm thinking another way. If we just look at the at the x at the x-axis, see how many trials there are. So we saw 8, so we can see n equals to 8. The x-axis is the number of trials, so we can see n equals to 8. And we go to the probability and we see the the tallest column is to which probability, and is to 0.3. So we can see the probability of it is 0.3. Like I'm just guessing it. And I think look at the x-axis and look at which is the tallest can solve the question. But if you have another way, please let me know. Okay, let's go to the next question. It's not easy at all. A test for oh, is this word extrasensory perception (ESP) involves asking a person to tell which of 5 shapes: a circle, star, triangle, the diamond, or heart appears on a hidden computer screen. On each trial, the computer is equally likely to select any of the 5 shapes. Suppose researchers are testing a person who does not have ESP, and so is just guessing on each trial, which is the probability that the person guesses the first 4 shapes incorrectly and gets the 5th one correct. Oh, this one should be easy because there's only one correct, so the probability of getting incorrectly is 4/5. And it's to the power of 4 because you have 4 incorrect. The first 4 shapes are incorrect, and then you times the probability of you get the 5th one correct, which is 1/5, and it didn't ask us to calculate the answer. It just tells us to write on the calculation. So we know it's C, 4/5 to the power of 4 times 1/5. C. Okay, we've finally done all the questions in the chapter 6 practice test. It's just 10 questions, but they are not easy. Not easy at all. Okay, goodbye. See you next time.